Hello students. So today we're going to discuss about the linked list. So what is that? That is basically another linear data structure. So what I meant linear data structure? Linear data structure means which is basically organized in the memory in some linear order. More specifically, if the elements are maintaining a relationship of adjacency, then you can call that it is a linear. Now, till now we have learnt about the array. So what is this? In case of array, this kind of contiguous allocation we can observe that here is it's just a memory chunk, and there is one by one elements supposed to be stored here one by one, right? So this is now there is two style. In one style there is continuously you need to store, you need to give the array specific size. Now it may be the 100, it may be the, if it is 100, then maybe the requirement is for 10, then there is a wastage of space of 90 element. If there is, you have given 100 but the requirement is for 150, then there is an extra requirement. So for that we have learned also there is another way to dynamically allocate the space. So for dynamically allocation of the space we have what? For dynamic allocation of the space we have malloc-calloc function, right? Dynamic allocation, fine, that is also very good. Next, what else is required? Next, the requirement is that sometimes it may happen that your array is all time requiring what? Your array is all time requiring the contiguous allocation. Now, contiguous allocation may not be possible. Fine. Contiguous allocation may not be all time possible, means for example, suppose this is your entire memory. This entire area is your memory. Fine. So this is a blocked area. This is a blocked area. This is a blocked area. This is another blocked area. So all these are blocked area. This is also suppose blocked area. Now there is a requirement, suppose the entire thing, that this is suppose the entire thing is a 500 MB, and you need to store or you need to use, and there this is total 500 MB and already occupied, for example 400 or 420 MB. Now 80 MB is vacant at present. Now the requirement is that you want around 70 MB, but it may possible that 70 MB is available as 80 MB is available, so 70 MB is also available, but the point is it may happen that it is not present in a contiguous manner. That is a problem that you may face. Then what you need to do? Then you need to use all these free spaces, all these free spaces. This is a free space, this is a free space, this is a free space, means all the unused spaces you may try to use. These are the all are free spaces. And not only use, if you want to go it for a list of elements, you need to store the elements in different area, and then you need to do something that you should able to track them. And here is the concept of linked list. The concept is that they will take all these unused block, maybe, or all the free blocks, there they will assign some they will assign particular data, and then they will also try to catch the details where the next part of data is being fixed. So the concept is that there will be one memory allocation which in one part will contain data. This part will contain data and this part will contain a link. Fine. This part will contain a link. Fine. Now why this is important? One part in the memory, in the free space, one chunk is found, so the user data is going to be stored there, but as there is a chance that you maybe you are in a need in multiple chunk, so there is a requirement that you should create another node in somewhere in another part of the memory with again a data part, and again a link part. So these two are two different address. So this node, if it is a list, this link part must be added to this node. That is the thing. Linear doesn't mean that they will be placed side by side. Yes, it's possible that they are placed side by side, but that is not obvious situation in case of linked list. Fine, that is not at all a obvious situation in case of linked list. So this way they can do. So again, if another node is there, then it will take. Now obviously there is no such physical arrow. What is there? This part is containing the address of this location. This part, this link part or this part is containing the address of this. Now if it is the last node, then there will be null, means there will be no assignment of any address. So what is a linked list? It's a collection of nodes. Linearly they are adjacent to each other. Now in case of single linked list, they are having the connection only in one direction. They can go in only one direction. There is no backtracking. Fine. They do not have any option to backtrack. Means the last node cannot point to the first node in case of single linked list. Single link, they can go in one side. So this is the concept. So every node must contain one data part given by the user and another part that must be the link part. Which must contain some address of another node. Fine. So this is all about. Now how we can program, how we can write the program. See, in this part, this is a memory chunk. So how we can deal with till now memory chunk? Now with the array, but it contains all the similar type of element. But if there is a requirement that use the memory efficiently in such a way so that there must be what I can say, there must be different kind. One is data part and another one is link part, right? So different type of data. So you need to take what? Either structure or union. Now you cannot use the union. The reason is, in union entity you can use at a time only one data member. So you need to use structure only. Fine. So we will use the structure in case of programming. We need to define this node and we will take one data member and one link member. Now it's not a normal structure. It is a self-referential structure. Why? Because one structure or one node has to hold the address of another node. Now, what is the node? Node is another structure. So, within the structure definition, you need to use a pointer variable which is the type of itself, self type. So, it is a self-referential structure. So, now I will show one implementation of the single linked list and different operations. Now, what are the operations I can do? Definitely creation, then creation of different node, that is the insertion of the node. Now, insertion may take this way one by one, or may take at some particular place specified by the user, and we can delete. So, these are the operations that can be performed. Fine. So, now I will directly move to the coding area where I can show you the code and I can explain you line by line. So, I am just quitting the board and then I will move to that part. Fine. So, that is the next thing. So, next we'll discuss, I have discussed the theoretical thing. Now we will discuss the implementation using this C programming language. So, what I have told that in the entire thing, the one thing we need to assure that your node should be able to take different kind of data type. So, now different kind of data type means what? It may be anything. Now, in case of node, there is one data and one is the link part. One data part is there and one link part is there. See, and that must be a structure, self-referential. Struct is the keyword to define the structure. Node, then one integer data part I have taken. You may take any kind of data type, that's up to your choice. Next, this struct node, then the pointer. So, this symbol is for pointer, and see, this is the type of the struct node. Fine. This is the type of the struct node is there. So, this is all about this is just the node definition, and you need to declare this outside all the function. Now, I have taken standard input output function. I have taken the standard input output header file for normal input output operation, standard lib library for few of the function, malloc for the dynamic allocation function. Now, first I need to take one particular pointer variable of the type node, means when nothing is there, still I am considering that will be the starting node named as the start. So, start is there and I am assigning it with the null. See, this NULL null, it has to be written in the capital letter. It is a macro already defined in the system. Fine. Means there is nothing. Nothing is there. So, that is NULL null. Then, what are the operations I can do, or what are the operation I am supposed to do with this linked list? These are the few. It's not necessarily that only this many operation you can do. You can do more than these operations, but we are doing only this at present. So, there is one create function, then there is one insert at beginning function, insert at end function, insert at any position, displaying the content of the linked list, then the count, that how many nodes are there, then deletion from different position, beginning, end, or any position. Fine. Next, go in this way that there is a menu. There is a menu is given, and you are taking the input with this, one for create, two for beginning, end, insert. So, these are the individual count or individual number. Those will be taken in the input part. These are the just the menu, that what to do for what. You just take the choice under one infinite loop and then do this. Under from the switch case, call one by one function as per your menu. Just do the function calling. Fine. So, we need to understand properly that how to do all these, how to implement all these functions, that is individual operation. Look at the create function. So what to do during the creation? During the creation you need what? During the creation you need one data part, and if it is the first node, the link part can be considered as null. If it is not first node, then the link part must be assigned to some another node. Fine. If it is first node, then the link part can be null. If it is a new node, then it must be attached to the link part of the previous node. Now see what I have done here, that I am taking the input for the first time, declare two variables, one is for new node and p is for temporal, for different kind of manipulation. See, I have just taken this is as a breaking condition, that if n is equals to -1, the loop may break. So you can take anything for that. Fine, for loop breaking you can take anything. Then using the malloc function, I have allocated a space for the node and storing the address in the new node. So that is fine. Next, assigning the data part to the new node, and then as it is the first node or just you are creating the node, creating the link part as null. So one node is being created where the data part is assigned and the link part is assigned as the null. Fine. Next, if start means, what is start? I have declared initially it as start. I have declared it initially at the very beginning, that start, that is the first node. Fine, starting node type of concept. If that is null means the node that you have created using this new node statement, if it is the first node, when you will consider it is as first node, if it is null, then only, then start equals to new node. So new node will be assigned to the start. Now if that is not the first node, then what you will do? Then you will assign start to some temporal pointer variable of type struct node. So assign the start and check whether the link, whether the next node exists or not. If next node exists, then just go forward. P equals to p arrow link. P is initially pointing to the start, so p equals to p arrow link means then it will going to point to the second node. When it is in the second node and the third node link is not null, then it will point to the third node. So this way it will continue, and once it will find that this is the last node link is null, then that p link will be assigned with the address of the new node. What is new node? This is the address. This entire memory allocation will return one address of the node that is stored in the new node, and that will be assigned here. So this is how you can create. Now how you can continue? Again you will take the input, and if it is not -1, it will be continued in this way. Fine. So this is about the creation, how you should do the creation. Next we'll discuss the display function. So what to do? We need to display the content of the node. So for that, again take the temporal variable of node type, and that nature is pointer, because you are going to deal with the address. Then again you assign the start in the p, and start is declared outside of all the functions, so all the function can access it globally. So if p means while p not equals to null, means if the node exists, it's not p arrow link means whether the next node is exist or not, it's about whether the node exists or not. If it exists, then you printf the data. See, whenever you are dealing with the structure, the individual structure member can be accessed either the dot if it is a normal structure variable, and if it is a structure pointer, then you need to use the arrow operator. This is arrow operator, one hyphen and then this angular bracket, this is arrow operator. So you are accessing the individual node element as printf p arrow data. Now once you have printed this, you can proceed. So how you can proceed? P equals to p arrow link, because p arrow link will contain the next node address. So this is about the display. Next is insert at beginning. So what you need to do basically, insert at beginning means there is already one existing list. The node you have created, you will fix it just before the start, and once you can fix it before the start means this new node link part must be assigned with the start, with the present starting node, and once the linking is done, then this new node should be taken as the start. See what I have done here. I have taken one new node variable for the new node creation, one int is there for data part, then taken the input or taken the memory allocation in this way, then there will be again data part assignment in there, and here is the main thing, new node link equals to start. Fine, start is the present starting node address or starting position of the entire linked list, so you need to take the start there. Your new node next part must be attached to this part, and then this new node must become starting node. So now the new starting node will be this new node. Fine, so this is how you can do the insert at beginning. Insert at end is exactly similar to your creation of the linked list when there is more than one node, means the else part. See, again I have done this, p equals to start, p arrow link, if not equals to null, then this must be done. So that is insert at end. Next, insert at any position. So insert at any position means you will ask the user that where you want to enter the data and which particular data you want to enter. Now for insert at any position means you can go for this way, that you can go after some node, you can go after some, before some node. So for that what you need to do, you need to take first of all two choice from the user, the number you want and after which you want to, means see, in case of linked list you cannot identify this with the position. Yes, you can identify by counting the number of nodes, but that is not that much user friendly way. If you have the flexibility that you can ask that after which particular value, considering that all the values are distinct or whenever the first occurrence of the value is there, you can insert. So it's just the way how you can manipulate the pointer. This function I am showing here how to manipulate those pointer properly. So these two steps are very obvious: allocation of the node area, then new node data equals to n, this part is done. So what you need to do, you need to start from the very beginning. You need to check whether the data part of any node is matching with the given m for monkey, means after which you want to insert. If it is, then you need to keep the address of that node, then you need to keep address of that node and the address of the very next node. Why? Because now you need to make the space in between, to make the space for the new node in between two node. Which two node? The node which that you just have crossed and the node which is just after this. So you need to maintain that too. Fine. So this way you need to do that. So next is that how we can implement this. Look at the code, that while p not equals to null, data equals to m, then q equals to p arrow link. What is p? Now where the data is matching. Fine, suppose there are 5 nodes and at the position of node 3 the data is matching. So what you need to do, you need to connect the new node at the link part of the second node, and the new node link part has to be connected to the next node of the fourth, means the new node has to be connected in the link part of the third node, as after the third node you want to insert, and the link part of new node should be assigned with the address of the fourth node. So suppose P is your third node where the data is matching. So in some queue, another variable of struct node type, you are storing P arrow link. P arrow link means the address, the next node address of the P. So next node means fourth node. So fourth node address is stored in the queue. Fine. Fourth node address is stored in the queue. Then P arrow link means the present node, that is the third node. That link part, that pointer part is assigned with the address of the new node. Fine. So 1, 2, 3. After 3 you are supposed to insert. So 1 link that is being prepared by this line. P arrow link equals to new node. Fine. Now right hand side of the new node is still pending. So what to do? It has to be connected to the previously fourth node. So previous fourth node address is stored in the queue. So new node arrow link equals to queue. Done. So you do all these things if the data part is matching. Otherwise you just need to proceed. So it is insert at any or insert at after some particular node position. Then there is one count function by which you can just count if the P is not null. Just a counter variable is set that how many nodes are there. Using just a proceeding P equals to P arrow link, you can count and you can print the number of nodes. Fine. Next is delete at beginning, end and different position. Deletion means obviously you need to free the allocated space. So what to do? Delete at beginning means you are supposed to delete the start, that is the starting node. Now before you delete the starting node, you should make the second node as your start. If you do not do that, you will lose the complete linked list. Fine. So first you check if start equals to null, then there is no list. Otherwise you should start with P equals to start. Fine. Then start equals to start arrow links. Means second node address is stored in the start link part. So now you are going to make the second node as your this node. So start equals to start arrow link must be there. So start supposed to be assigned with this one, right? And then okay, now start is free, means this location which is previously pointed by the start and that is stored in the P, you can make free that. So you can make free that. That is your deletion at the beginning position. Next is deletion at end, that is the last node you want to delete. So last node you want to delete means you need to reach till the last, means you need to identify for which node the link is null. Fine. You need to go up to that position, and when you are going that, you need to every time you need to keep a back process or need to make a record that which one is the just previous of this node, cause whatever the link for the last node is null, for whichever node after the deletion of that node, just the previous node link has to be made null. So again P equals to start and another variable is being taken, Q equals to P. Initially both are pointing to the start. Next, P arrow link, while P arrow link not equals to null means you are checking continuously whether the next node exists or not, and you are copying Q equals to P. Before you proceed the P, Q is pointing to the previous one or the present one. So P, that is the present node, address of that copied into Q, then P proceed. You will continue this procedure till the next node is null. Once you are getting it as null, then that means P is pointing to the node for which there is no next node and you are keeping the previous P or the P address in the queue. So then you can make, after you reach the last node, Q arrow link equals to null, and then you can free the position held by this particular thing. Next, delete at any position, almost the same concept, that again p equals to start, q is every time pointing to the p. Now the task is different. Insert at any and delete at any are basically two different, completely just opposite operations. So what you need to do for that, you need to do it in this way. While p arrow data not equals to n means the node you want to delete, means that is again the value based thing, not the position based. Keep the present thing in the queue and the proceed in this way. Once you are done, means now suppose you want to delete again the third node. Previously in the insertion at any, you have tried to insert it after the third node, and now you want to delete that. You want to delete arbitrarily that particular node. So what you need to do, you have kept the previous node link, you need to address it or link it to the next node. So p, for the p, the previous one is maintained in the queue. Fine. So q arrow link is actually what means you need to delete this. So p arrow data not equals to n, you are supposed to proceed. So whenever you are proceeding, you are going in this way. So q is holding the present p address. Fine. So in that particular node, after that node you will actually want to delete that particular node which is pointed by p. So whatever the node after the p, that is p arrow link, so you need to assign it in this way and you need to free it. So this is just the different function or simple functions of your single linked list implementation. There are more functions are there. If you have understood the concepts properly, you can implement them. Thank you.